Hey everyone! So our next unit is on similar triangles. So this is going to be sort of like congruent triangles, but instead of congruent, they are similar. So we're going to see that difference as we go through these notes. Your learning target is that you will be able to use SSS, SAS, and AA theorems to identify similar triangles. So the word similar means similar, like you're sort of alike, maybe you and your friends have similar interests. The difference between similar and congruent for triangles is going to be that congruent triangles, all of the parts were the same. We said same shape, same size, but similar is going to be the same shape, but a different size. So just as they're called, similar triangles are similar to congruent, but they are not exactly the same. So here I want you to write whatever helps you. How will you remember this? I will be looking to see you've written something here. I want to see that you are thinking about what the difference between similar and congruent is. To give you an example that is not math, I like to think about dogs. So I like black labs. So if you have two black labs, those dogs are exactly the same. So that's going to be like congruent dogs, if you will. But if you have a black lab and a puppy, well then they're both the same shape. They're both dogs, but they're different sizes. So that's kind of your example of similar. So to compare similar triangles, we're going to write things called extended ratios. So the extended ratios help us compare sides of similar triangles. So if I look at these two triangles here, I'm going to use a color and start with side PE. Well, side PE in this triangle I see compares to side DO over here. So to write the ratio, I'm going to use some fractions. And I just write the ratio of those two sides. Next up, I have side ET compares to OG in the other triangle. And then last but not least, PT and DG. So you might see that I wrote an equal sign between each of these. Because these are similar triangles, the ratio between the similar sides in the two triangles is going to be the same ratio. If they are the same ratio for each of the compared sides, then you know that, yes, those are similar triangles. So now, if we look at those same triangles right here, but with some numbers for the side measures, we can write our ratio again. So again, I had PE and DO, but instead I'm going to write the numbers. So I have 6 over 3, PE over DO. Next up, I had ET and OG. So I'm just looking at my ratio I'd written up here. I see that ET is 10 and OG is 5. Then I have PT and DG. And I end up with 14 over 7. So if I typed each of these into my calculator, or divided both the numerator and denominator by the same number, I'm going to see that each of these little ratios is going to simplify to 2. Right? 14 divided by 7 is 2, 10 divided by 5, and 6 divided by 3. So what do you notice about each of the ratios in the extended ratio? So each of the ratios in the extended ratio, they all simplify to the same number. Or sometimes it might be a fraction. Put a little star here by these words scale factor. So a scale, just like a musical scale, you can go up and down the scale. We can scale numbers. So if I have 3, I could scale 3 up by multiplying by something. So if I multiply, it scales up. So just as you may think, if we can scale up, we can scale down. So the opposite of multiply is divide. And so divide scales things down. So these two operations are things you're going to be using to decide each of your ratios in your extended ratio, what the common scale is. So in this case, we could scale all of them down by dividing by 2. Or excuse me, dividing by the denominator gave us 2 for each of them. All right, after you've finished that, we are going to flip it over and look at those 3 different theorems for similarity. So our first one is called side-side-side similarity. Again, I want you to write in this box how you will remember this after we've done this example. But something that I want you to note is that you need to start with the smallest number always. So, side-side-side similarity, you're going to have only 3 sides marked. And we're going to write those extended ratios we wrote on the front of the worksheet. So first thing, I had a little bit of a typo on these, so you need to change the 18 over here to a 24 and change the 22 over here to a 30. So fix these numbers. It should be 24 here and 30 here. So the very first thing I want to do is write an extended ratio. So since I said start with the smallest, we're going to color in the smallest side, the smallest measurement on each triangle. I see I have WO is to DA, and I'll go ahead and write the numbers too. So WO was 16 and DA was 20. Next up, we've got 20, which is our next biggest number, and 25. So I start with the smallest and go up to the biggest. So 20 is side OP, and then we have side AB, and that is 20 over 25. And then last but not least, I've got those 2 sides that I needed to fix my typo. PW over BD equals 24 over 30. So if you take a second and figure out what we could divide or simplify each of these fractions into, you might notice that if you divide each one of these by 4, or if you divide each of these by 5, you divide each of these by 6, you're going to end up with all of them simplifying to 4 over 5. So since each of those ratios, since each of the ratios in the extended ratio here simplify to 4 over 5, then we know that yes, these are similar. So I can write my similarity statement just like we did for congruency. So I'm going to write that triangle WOP is similar to triangle DAB. Just like with our previous unit, you want to make sure the order matters. So I did my blue side, my green, and then my pink in the order that I named these triangles. All right, we got 2 more, so slide your paper down a little bit. Before you do that, make sure you write in this box something that will help you remember side-side-side similarity. After you've done that, we are going to look at side angle side similarity. So what we can look at here is obviously there's only going to be one angle marked. So I see that in this triangle that is angle D, and in this triangle it is angle V. So because these are the exact same triangle or exact same angle, we're using that congruency theorem or symbol again. Because these are each 90, we're using that congruency symbol to show us that these angles are congruent. But now, since we have similar triangles not congruent, we're looking at the extended ratios of the sides. So I am going to use my colors again and start with that smallest number. So in this triangle it is 3, and over here it is 6. So the side that is 3 is side AV, and over here that is FD is the corresponding side. If I want to leave some space and write in the numbers, I have 3 over 6. And then I move on to my only other sides that are labeled. I have VQ in the first triangle and then DM in the second triangle. And that has the ratio of 4/8. And again, if you take a second and look at these, 3/6 can be simplified to 1/2. And 4/8 can be simplified to 1/2 as well. So since they both simplify to the same fraction, then we know these are similar, and I can write my similarity statement. So I'm going to say triangle FDM is similar to triangle, let's see, I went down my green side to that right angle, so I'm going to go along the green to the right angle, AV, and then down the blue side, Q. All right, when you are done with that, take a second and write in this box how you will remember SAS similarity. I'm going to make a little note here that you might want to add is that the angle is in the middle. The angle must be in the middle of the two sides. All right, we just have one more similarity theorem left. So scroll your paper down to angle-angle similarity right here. This time, the way to help you remember angle-angle is that usually none of the sides are going to be marked. So we're just looking for angles that are the same. Well, one of the very first things I always said in the congruency unit is remember, when we have angles across from each other like that, they are called vertical angles. So we know vertical angles are congruent. So angle C is congruent to angle C. So angle-angle, I only need two of them. I have one angle now. I need to find another pair of congruent angles that will tell me these triangles are similar. These little arrows here tell me that these lines are parallel. So if I mark these two angles, this is a throwback to our first unit of the year. On alternate sides, you've got alternate interior angles. And because these are alternate interior angles, we know they are congruent. So angle A is congruent to angle E. Because those are congruent, we now have two pairs of congruent angles. The last thing we need to do for this example is write our similarity statement. So if I say triangle ABC, then that triangle is similar to EDC.